As I observe your groups working together while you were taking the study team test, I was encouraged by some of the conversations I heard about this problem. I think a lot of us are getting more and more comfortable with dealing with these types of things. Um, and because of that, I think my explanations are going to get a little bit more concise here as we move forward. But again, if this doesn't make sense to you and you don't understand um, why I'm getting the things I do, please come and see me. So first of all, when I look at this first chunk, it's something raised to the third power. So that means I have three factors of this whole chunk, right? It's three of those. And I know the shortcut. I can take and I can raise each one of the individual terms. I'm sorry, each one of the factors in this to the third power. So I can take, for example, 3 to the third times a to the third times b to the third times c. If I have c squared and I raise that to the third, that would be c to the sixth power. So this is equivalent to this first entire chunk, right? That whole thing. The other thing that I see is that this other chunk is being raised to the negative second power. So rather than deal with, well, actually, you know what? I could raise each one of those. I could do the exact same thing. Never mind. So this would be equivalent to times a to the negative second power times b to the negative eighth power, right? 4 times negative 2 is negative 8 times c to the negative second power. And that works as well. So now that I have these, I can see that there are some bases that are the same that I can bring together in this massive product. So for example, I've got a to the third, and over here there's a to the negative second. I also see that I've got b to the third, and I've got b to the negative eighth. And the other thing I have is c to the sixth and c to the negative second. So we're going to bring all those together as we simplify this. The other thing is 3 to the third power is 27. I guess I'll just write that because there's nothing else happening with that. So we're going to write, I'm going to write this is going to be 27 times. Now, in terms of the a, I've got a to the third times a to the negative second power. Well, that's just a to the first, right? So I'm just going to write a single factor of a times. Next, I've got b to the third times b to the negative eighth, which is b to the negative fifth power. And I guess I'll just write that now, b to the negative fifth power. And then finally, I've got c to the sixth times c to the negative second, which would be c to the fourth. So we've got times c to the fourth power. The final thing that I would do with this is terrible. My 5 looks like a 3. The final thing that I would do with this is deal with the negative exponent, right? We don't want to leave a negative exponent in our final answer. So to deal with that, of course, we know that those I could multiply by a giant 1 and go through that entire process. Or at this point, we could just simplify it and say, hey, this is 27 a c to the fourth power over b to the fifth. And if you're wondering how that happened, that those factors of 5 magically floated to the denominator, became b to the positive fifth, come talk to me and I'll review how we used giant 1s to make that happen. So that's our answer for part A. For part B, I guess in my numerator I've got 5 squared and then x to the fourth. So let's just start this here. I've got a 5 that's going to get squared times an x to the fourth power, and then times, it's just a 3, not 3 to the third, and then a y to the third, and then all of this is going to be over y times 5, or I'll write it as y 5 times y, same thing. There's some common factors here. When I look at the 5 squared, right, that's a 5 times a 5, and in my denominator there's a 5. So I can see that this is going to leave just a factor of 5 in the numerator only. And and then there's an x to the fourth, and there's a 3. Then I've got y cubed over y. Well, that's just going to be y squared. So it looks like everything that was in my denominator is gone now, right? Because y to the third power over y squared is just y. So what I'm left with is 15x to the fourth power y to the second power. So there we go. 15x to the fourth y squared is my answer for part B. So that's all of question 6.